Hey guys, Miss Dyer here. I'm not showing my face right now because it's Sunday night at 11:30, and I'm gonna go to bed in a few minutes. And I don't look the best in the world. I've had a shower, my hair's not combed, so therefore I decided to do a video without my face today. But you'll get to see me tomorrow if you get on at 8 a.m. I wanted to make sure that you remember that you need to purchase the eText McGraw Hill Connect program by going to this website that I've given you here. Um, I need you to have this done by Thursday. I plan on Thursday giving you a lab exercise on McGraw Hill Connect, and you won't be able to do that if you haven't purchased it yet. As I've said on Google Classroom a couple of times, if you are going to have trouble paying for this, please let me know. Please email me and let me know that. So I need everyone to have that by Thursday. I wanted to give you a little bit of a tutorial on how to do that. So when you click on this web address here, it's going to open up. And what you want to do is you want to go to the digital purchase option. And when you go to that, there's what we need right here. You're going to say buy now. And then you're going to check out. It's going to ask for an email address. You're basically going to have to create an account. At one point, it's going to ask you for your school, and you're going to put in Campbellsville University because this class is through Campbellsville University. And then at some point, it's also going to ask you for the section web address, I do think. And this is going to be, I've given it to you right here, this is your section web address. If you go all the way through it and you create your account, but it doesn't ever ask you this, then for this section web address, you can actually click on that. And right here, once you've created your account, you can log in to our class by putting your email in right here, and that will join you to my class. It's called Fall 2020. Dual Credit Anatomy and Physiology Bio 221 Campbellsville University Fall 2020. And I misspelled Campbellsville University. I'll have to go back and change that. But anyway, so at some point, if it doesn't ask you for that section web address, you can just click on it here in the syllabus, and it will take you to the place where you can put in your email for the account that you created, and you can join our class right here. And then I will go over how to use it more before or during my video for the lab on Thursday. Okay, so what we're going to be doing today is we're going to be talking just briefly about Chapter 1. Now, you guys, I'm not going to go over every single slide, every single word on every slide in this PowerPoint. So, you are seniors, you can read. So I'm going to leave a lot of this for you to read. Probably starting with Chapter 2, I will assign some reading on the McGraw Hill Connect program for you to do and answer questions about. It's kind of like a guided reading exercises. I'll do some of that. And then I will just briefly go over things that I think that you might have trouble with and things that I just want to emphasize in the chapters. So looking at Chapter 1 really quickly, because I don't want this to be a really long video. Anatomy is more about the body's structure and how its structure allows it to function. Something that's interesting here is that no two humans are anatomically the same. Everybody has a little bit of anatomic variability. An example, it's called an anatomical anomaly. An example is the muscle called the palmaris longus, which you learned about that if you had anatomy last year. If you take your pinky and put it to your thumb, if you see this little indentation here, this little thing sticking out, that is the palmaris longus. And notice you want to bring your palm a little bit toward your forearm. When you do that, bring your palm a little bit toward your forearm and your pinky and your thumb touch. If you see that little protrusion, then you have a palmaris longus. If you don't, then you don't have one. Some people have it, some people don't. So there are a lot of anatomical anomalies. Like, for example, my husband is missing a vertebra in his neck. He's missing, you're supposed to have 7 cervical vertebrae. He only has 6. Does that hurt him? No. If he had that extra one, he would be an inch taller, but he doesn't have it. That's okay. So, people are not anatomically identical. They are anatomically similar. Lots of different kinds of anatomy that we can look at. We have macroscopic anatomy or gross anatomy. That's like when you dissect the cat, we're looking at the gross anatomy of the cat structures. You can have regional anatomy, which is what you study in medical school, like when I dissected the cadavers. We dissected the chest, we dissected the abdomen, we dissected the upper limbs, we'll dissect the lower limbs. So we're studying the body by region. Systemic anatomy is what we study in this class. We look at different body systems. So we study the muscular system, we study the skeletal system, we study the cardiovascular system. So we study them by systems. Surface anatomy is looking at the surface of the body. We also have microscopic anatomy, looking at cells and tissues, for example. Lots of different ways we can take images of the body, both externally and internally, and this is just kind of an overview of all of those. On each one of the slides after this, I have some specific differences between them. For example, X-rays give you two-dimensional images only. Bones are going to appear white. Cartilage and empty space will appear black. Ultrasounds use sound waves to form an image. A CT scan, you've heard of that. It creates a 3D image by doing slices through a body or an organ. A DSA also creates 3D images. It's more like an X-ray, but it does give you 3D instead of 2D. You can read more about that. There's MRI. I'm sure you've heard of that. It's better than a CT, specifically for detecting different types of cancer. Then we have a PET scan. It's also useful in detecting cancer because it helps you to analyze metabolically active cells and tissues and organs. So cancer is going to be more metabolically active than normal cells and tissues because it's dividing uncontrollably. So therefore, a PET scan is often used to detect cancer as well. Physiology goes with anatomy. Again, anatomy is more about the structure and how the structure allows it to function. Physiology is looking more at the function and looking at how it functions and how we can predict the body's response in terms of understanding the function. We also need to understand homeostasis. Again, homeo is same, stasis is staying, so this is literally staying the same within a narrow range of values inside your body. So again, the body maintains relatively constant or the same internal conditions within a narrow range. Moving on, you do need to be familiar with the different levels of organization, starting with the chemicals like the molecules, the atoms and molecules that are inside of cells. Cells are the the smallest level of living things, okay? So anything smaller than a cell is not living. Atoms and molecules are not living, but cells are. Cells come together to form tissues. Tissues form organs. Organs form organ systems. And then organ systems come together to form organisms. We have about 11 organ systems in our body. The integumentary system, if you remember from last year, is the skin. Again, you need to be familiar with some of the parts of these different systems as well as what their functions are. So again, different parts of the integumentary system and what the integumentary system does for you, such as regulating temperature, helping to produce vitamin D, preventing water loss, protecting you from pathogens getting in, and things like that. The skeletal system will be your bones. In addition to holding you up and helping you move and supporting your body, it also produces blood cells and stores minerals and fats. The muscular system, again, includes all of your muscles. In addition to helping your body move by being attached to bones and moving those bones, it helps to hold your body upright and also produces body heat. Your lymphatic system, this is going to give you your immunity. It helps to remove foreign substances, but it also helps to maintain tissue balance. It's going to include things like your lymph nodes and your lymph organs. Your spleen is also part of your lymphatic system. Your respiratory system, again, we know it helps us to breathe. It includes our lungs, but also other things. It, in addition to exchanging carbon dioxide and oxygen, it helps to regulate our blood pH. Our digestive system, again, liver, gallbladder, intestines, things like that. In addition to helping us to digest food and absorbing it, it is going to be helping us get rid of waste. Our nervous system, including our brain and spinal cord, is going to not only give you your personality, make you who you are, it also regulates your body's physiological processes, and it helps you to interact with your environment and move as well. The endocrine system, all these are endocrine glands. it influences your metabolism, your growth, your reproduction. All of these glands secrete hormones which regulate these activities. Your cardiovascular system is your heart and blood vessels. In addition to containing the blood, which transports nutrients and waste, it also transports hormones and oxygen and things like that throughout your body. It also has white blood cells, which participate in the immune response, and it helps to regulate your body temperature by transporting that warm blood to keep cells and tissues warm. Our urinary system includes our urinary organs like our urinary bladder and our kidneys. In addition to removing waste from our blood, it also helps to regulate our blood pH and our water balance. And then we have the reproductive system. Again, we have female versus male reproductive organs. Again, we know mainly that is for, reproduction, obviously producing the next generation. But in addition, it's going to be producing hormones that affect not only sexual function, but also in females, for example, producing milk. In males, producing that semen that contains the sperm, which is the reproductive cells. Okay, we have characteristics of life here. You want to know those 6 characteristics of life and kind of what it's referring to. Again, you can read about that. And then moving on to, we need to understand homeostasis in order to understand feedback systems. So homeostasis, again, you have a set point or a normal value, and then homeostasis means that certain values can kind of fluctuate above or below that to a certain degree. So, for example, if we look at body temperature here, normal for most people is 98.6 degrees Fahrenheit. That's 37 degrees Celsius. But we can fluctuate above and below that a little bit. Maybe when you're exercising, you might get a little bit above that. When you are cold, you might get a little bit below that. So, 98.8 would not be considered a fever. 98.4 would not be considered you're freezing to death. But most people stay in this narrow range of values around that set point of 98.6. It's important for us to understand set point, to understand feedback mechanisms. The set point is the normal range of value. It's the normal value for, in this case, we're talking about body temperature. For heart rate, it might be 70 beats per minute. For blood pressure, it might be 120/70, or that very close to that value would be the set point. So we have feedback systems that help to keep our body around that set point. They help to bring us back down. The negative feedback system helps to bring us back down if we get too high, and the positive and it also helps to bring us back up if we get too low. That's the negative. It decreases the deviation from the set point. So if our body temperature gets too high, a negative feedback system would bring it down. If something gets too low, then the negative feedback system would bring it back up. So it's called negative because it decreases. It brings you back to that normal set point. The positive does just the opposite. It increases the deviation from set point, so it takes you away from that normal value. So you might think, well, how in the world would that be useful? If we have a normal value and this positive feedback takes us further away from that normal value, how can that be good? Well, we'll look at some examples of how that can actually be positive sometimes, but there's also some examples of the positive feedback that can actually be that are negative. Okay, so the components of a feedback system, first of all, is the receptor. The receptor is the structure in your body that's monitoring the value. It's monitoring the set point, okay? It's monitoring your body and making sure that it is staying at that set point. That is going to be the receptor. The control center is the structure of your body that is establishing the set point. So it sets the set point, and usually that's going to be some part of your brain, okay, that sets that set point. And then the receptor monitors and makes, is my body around, is it close to that set point? And then the effector can change it. So again, the effector is the one that's going to bring the value back down if it gets too high above, or bring the value up if it gets too far below. Or, if we're talking about positive feedback, the effector could be actually increasing, making it go further above the set point or further below the set point. The stimulus is going to be the thing that's making the deviation happen. and it is going to be detected by this receptor. So the receptor is monitoring how our body is around that set point, and the receptor detects the stimulus. It detects our deviation from that set point. And then the response is produced by the effector. So again, the effector changes the value of the variable. So the response is it's going to be the thing that makes our body go back to normal, or maybe to go back further away from normal. Again, most feedback systems in our body are negative feedback, again, decreasing the value from normal. So let's talk a little bit about body temperature, okay? Let's say that we get too hot, okay? We're too hot. Well, the receptor is monitoring the value. In this case, this is going to be receptors in the skin monitoring our body temperature. So receptors in our skin feel that our skin is getting too hot. So the nerve receptors in our skin, temperature receptors in our skin. Usually these receptors are nerves or nerve cells. So we have temperature receptors in our skin that sense that we're getting too hot. And so what's going to happen in your brain, this information will be carried to our brain, to our hypothalamus. And so our hypothalamus is our control center. So our receptor is our temperature receptors in our skin. Our control center is our hypothalamus. Our hypothalamus establishes that our body should be, and it's going to be right around in here, it establishes that our body should be 98.6 degrees, okay? And so if our temperature receptors sense that we're getting too high above that, then that information is going to be taken to the hypothalamus, and then we're going to respond to that. So anyway, then you have your effector is going to be the structure that's going to respond. So once those nerve receptors send that information to the hypothalamus that you're too far above the set point, which has been established by that hypothalamus, your hypothalamus is like a thermostat, then that hypothalamus is going to send information to your sweat glands. Again, all this is happening by way of nerves. Nerves take the information from the receptors in the skin to the hypothalamus, and then information from the hypothalamus is being sent back through nerves to the sweat glands. Sweat glands are one example of an effector. They're not the only effector, but they're one example of an effector. So when the hypothalamus senses from those receptors in your skin that you're too hot, then the hypothalamus will send information to cause those effectors, those sweat glands, to produce sweat. Okay? And that sweating is the response. So again, the hypothalamus establishes the set points. The set point of 98.6 degrees. The receptor is going to be temperature receptors in your skin. They are going to say, hey, getting too hot. They're going to tell the hypothalamus that. The hypothalamus will then send information to the effector, the sweat glands, causing the sweat glands to sweat. Okay, the sweating is the response. So again, the stimulus is, I'm too hot. The receptor, the temperature receptors in our skin, sense that. They send information to the control center, which is the hypothalamus. The hypothalamus sends information to the effector, which is going to be your sweat glands, and then your sweat glands sweat. That is your response. Okay? So the stimulus is what caused you to get away from the set point. The receptor is what detected it. That's your temperature receptors in your skin. The control center is what established that set point, the hypothalamus. The effector is what's going to take us back to where we need to be. That's our sweat glands. And what is their response? They sweat. The sweating helps to cool us down. Now, you guys know that sweat glands are not the only effectors. What are some other things that happen when we get too hot? If you remember from last year, blood vessel dilation. So blood vessels can be the effector, and blood vessel dilation would be the response. We can have the erector pili muscles can be the effectors. That would be for cold. That would not be for hot. Sorry about that. So your lungs could be effectors. Your lungs are going to expand. You're going to start breathing harder. So your lungs can be effectors, and the response could be increased breathing. Your heart is going to beat faster. So the effector can be the heart. The heart is going to beat faster, and the response is the beating faster. So the heart is the effector. The response is beating faster. So lots of different effectors when you get too hot. Okay, let's look at positive feedback real quick. When the deviation occurs, the response is to make the deviation greater. Normally, most of these positive feedback mechanisms are actually not present in healthy people. There are a couple, for example, your blood clotting. The more your blood clots, the more basically it's the platelets that cause the blood to clot. And basically when you're bleeding, your blood your platelets will start secreting chemicals to cause the blood cells to get sticky and start clotting to form the scab and stop the bleeding. And the more chemicals that are produced, that is going to stimulate those platelets to produce more chemicals. So it's like you get more and more and more chemicals, more and more and more clotting to stop the bleeding. So that is an example of a good positive feedback mechanism. Another one is childbirth. Whenever a woman's uterus gets stretched enough, the baby gets big enough, and the uterus gets stretched enough, then then that actually stimulates her uterus to produce more hormone, which causes more contractions. And so and that causes more stretching. So the more the uterus stretches, the more hormone that is produced, which causes more stretching. So you see how the positive feedback mechanism kind of amplifies everything. It makes the deviation greater. So you go from, once the baby gets big enough, it stretches those stretch receptors in the uterus, and that causes that stretching. It tells the brain to cause this hormone to be released, and that hormone causes even more contractions. More contractions means more stretching, which means more hormone released, which means more contraction, which means more stretching. And so the contractions intensify until the baby is born. Then when the baby is born, the stretching stops, so the hormone stops being released, and so the contractions stop. And then it goes back to normal. So those are a couple of examples of normal positive feedback. A lot of positive feedback mechanisms are harmful. For example, when you are bleeding, when you're hemorrhaging, it causes the blood pressure to drop. When the blood pressure drops, this causes the heart's pumping to slow down, which causes the blood pressure to drop even more. And so again, it just amplifies. Dropping blood pressure, heart rate slowing down, the heart not able to pump blood as efficiently, and so more blood. The blood pressure just keeps dropping as the more bleeding happens. So again, it kind of amplifies the bleeding. Actually, I think the heart rate doesn't slow down; it speeds up. So the more you bleed, the more your blood pressure drops, the faster the heart beats to try to compensate for that, and then that causes more bleeding. So it amplifies the bleeding. So again, that's a bad positive feedback mechanism in your body. So what I want you to do, this is not think, pair, share. This is your exit slip. So on your Google form that I have posted for today, you're going to do this. I've already went over this. So if you watch this video, you're going to get this 100% correct. So you're going to identify the receptor, control center, effector, stimulus, and response for the feedback system that maintains your body temperature. Okay, so that helps to maintain body temperature, too hot or too cold. So is this positive or negative feedback? I've already went over the entire answer for that in this video. Please let me know if you have any questions. Hopefully this is posting at 7, so hopefully you will have watched it before our Google Meet at 8 o'clock this morning. If you have any questions, you can ask me between 8 and 8:45, or if by the time you've watched this that is already passed, then just email me and I can still Google Meet with you. Again, this is going to be due at 5 o'clock this afternoon. Please let me know if you have any questions. I'll talk to you later. Bye-bye.